In this video, we're going to take a look at factoring a more complicated trinomial. Now, before factoring this trinomial, what you should first do is write all terms on one side of the equal sign. Then make sure that you're writing the trinomial in order of decreasing powers of x. Then we can properly factor this trinomial. Now remember that you would be factoring this trinomial as products of binomials. So I want you to now pause the video and try to factor this complicated trinomial. So the first thing we should do is write all terms on one side of the equal sign. So I'm going to bring the positive 10 over to the left-hand side and it becomes negative 10. We're going to set this equal to 0. Now the next thing you should do is write the trinomial in order of decreasing powers of x. Well, this is already written in order of decreasing powers of x because the first term has x squared, then x, then no power of x at all. So it's in the proper form. Now we're ready to actually factor this trinomial. So we're going to factor this trinomial as a product of binomials. The first term in each binomial, in the purple here and here, should be factors of the 6x squared. Whereas the second term in each binomial in the light blue here and here should be factors of the value 10 here. Now the other thing to remember is that the combination of the outers and the inners should work out to the value of negative 7x. Now this is a lot to remember, or a lot to keep in mind. So let's start off easy. Let's think of two possible numbers that when multiplied together will give us this value of 6. Also think of two possible numbers that when multiplied together will give you a value of 10. Disregard the negative sign on the 10 for now. We'll throw that in later. So for example, two numbers that are multiplied together to give us 6 could be 3 and 2. Now another two numbers multiplied together to give us a value of 10 could be, say, 5 and 2. Now those aren't all our possible options, but it's one possible option. Okay, so this might work. However, what we need to remember is that the combination of your outers and inners must give you a value of negative 7. So that's the hard part. How are we going to figure this out? Well, the easiest way to do that is to cross multiply these values here. So if I cross multiply these values here, I'm going to get a value of 6. Then, if I cross multiply these two values here, I'm going to get a value of 10. Now you need to ask yourself, is there any combination of 6 or 10, whether they be positive or negative, when added together, would they ever result in a value of negative 7? Well, you're going to have to exhaust all possible options. So for example, if I had negative 6 plus 10, that would not equal negative 7. Well, what if I had negative 6 minus 10? Nope, still not negative 7. Okay, how about positive 6 minus 10? Still not negative 7. So you'll quickly realize that there's no possible combination of 6 and 10, whether they be positive or negative, that will work out to negative 7. So this here wasn't the proper combination. Okay, well then what if I actually change it up so that I have 2 times 5 instead of 5 times 2? Would any of those combinations work? Well, again, you have to cross multiply, so 3 times 5 would give me 15, and cross multiply the 2 times 2, which would give me a value of 4. So are there any possible combinations, whether positive or negative, that 15 and 4, when added together, would give me negative 7? You'll quickly realize that there's no possible combination of that happening. So again, 2 and 5 is not working for us. Okay, well what about if I were to do 10 times 1? 10 times 1 still gives me a value of 10. So let's try cross multiplying. 3 times 1 gives me a value of 3, whereas 10 times 2 gives me a value of 20. Is there any possible combination, whether positive or negative, with these two values that would end up with -7? No, again, there's not. So this wasn't a good combination as well. Okay, finally, let's try 1 times 10 and see if that one works. Cross multiply 3 times 10 gives us 30. Also, 2 times 1 gives us 2. Are there any combinations, whether positive and negative, where these two values added up would give us -7? Again, no, there's not. Okay, so we're running out of options. What can we conclude? All we can conclude right now is that maybe 3 times 2 wasn't the right option to get 6. Is there any other options to get 6 when multiplying two numbers together? Yeah, actually there is. 6 times 1 is another possible option. So this one, 3 times 2, doesn't seem right. Let's now try 6 times 1. 6 times 1 gives me 6. Now we have to start over. 5 times 2 gives me 10. When I cross multiply 6 times 2, I would get a value of 12. When I cross multiply 5 times 1, I would get a value of 5. Is there any combination of 12 and 5, whether they be positive or negative, that would add to a value of -7? Actually, yes, there is this time. Basically, if 12 was negative and 5 was positive, this would give me an answer of -7. So this combination here seems to work. Now, if 12 was negative, what would that mean? That would mean that this 2 would have to be negative, because when I cross multiply these two, I need to get a -12. So that seems to work. Okay, basically 6 times 1 needs to give me +6. 5 times -2 needs to give me -10. And cross multiplying these two needs to add to -7, which it does. So in this case, this is my option. Well, how would we actually write this as a product of binomials? Well, we would write it just as we see it. 6x plus 5 comes from this portion right here, multiplied by 1x minus 2 comes from this portion right here, equals 0. So here, finally, if we set 6x plus 5 equal to 0, and if we set x minus 2 equal to 0, solve for x in each case, then we're done. So x here would equal -5 divided by 6, and x here would equal 2. And those two are the only solutions for this equation here. Another method in factoring this trinomial would simply be the quadratic equation. Now the quadratic equation has the formula of -b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. So for our trinomial, our value of a would be 6, our value of b is -7, and our value of c is -10. So substituting those values into the quadratic equation, where x equals this, would be x equaling, again, our value of b is -7. So -7 plus minus the square root of -7 squared minus 4 times your value of a, which is 6, times your value of c, which is -10. And that's all under the square root, and this is all being divided by 2 times the value of a, where a is 6. So x would then equal +7 plus minus the square root of 49 plus 240, all divided by 2 times 6 gives us 12. So x would then equal 7 plus minus the square root of 289 all over 12. Finally, x would equal 7 plus minus the square root of 289 gives us 17 all over the value of 12. So then x would equal 7 minus 17 over 12. Also, x would equal 7 plus 17 over 12. Now 7 plus 17 over 12 gives us 24 over 12, which equals 2. And 7 minus 17 over 12 gives us negative 10 over 12, which also works out to negative 5 over 6. So these two values are the solutions to the trinomial above, which are the same exact solutions that we got using the previous method.